So let me begin. Hello, everyone. Today we're going to be talking about enabling continuous deployment using Azure, Terraform, and GitHub. Some of you may have heard of these technologies, but maybe have never had the chance to truly delve into them. And hopefully, by the end of today, you're going to be able to configure, deploy, and view a three-tier application consisting of .NET Core API, Microsoft SQL Server, and a React frontend, all deployed on Azure services. So let me just begin. Throughout the content of this slideshow, first of all, I'm going to show the architecture and solution design. Then I'm going to explain what infrastructure as code is using Terraform and how that works. Furthermore, I'll talk about configuration and the importance of that and how we can set it up with every changing run of the workflow. Then we move on to application deployment, which is basically, okay, we deployed our infrastructure. What are we going to fill it with? That's the answer to that question. Finally, GitHub Advanced Security. So what secret scanning is, what Dependabot is, what supply chain security is. Then I'm going to move on with the demonstration of doing all of this and wrapping everything up. And then I'll just explain what you could do to extend this solution that we've been working on today and how you can improve yourself. So the initial state of our system it's basically empty. There's nothing in there. Everything is just a concept of a presentation tier, a business tier, and a data tier. It's all theoretical, like what you've seen in university or read in a book, for example. But now we're in the real world and we want to apply this to something meaningful, something that can be used by different people and different users. 1 second. In the real world. So infrastructure as code with Terraform is basically a way to declaratively define all of your resources. So virtual machine, an app service, a SQL server, etc. And have them be deployed automatically according to a set number of steps dictated by a provider. So providers are plugins to interact with different services. So for example, for Azure, we use Azure RM to do all of our processes. All it is actually just a glorified number of API calls in the background, which Terraform does to communicate with that backend. Then we initialize Terraform so that it knows what to configure, what providers it needs to install, and such. Then after we're done with that and we write down our list of steps, we run the Terraform plan command to preview the changes that Terraform is going to make and just to confirm them, basically. Finally, if we're satisfied with the results, with the output, with what's going to happen, we can run the Terraform apply. Command to basically execute all of that and provision the resources in the real world. So over here we have some issues that may arise with infrastructure as code, which is configuration, but these can all be fixed. One of them is configuration. Since every time we execute our plans, for example, we don't want to have the same database password and username every time we provision our SQL server, or we may not want to have the same URL, etc., etc. So the way that this is handled is by using the outputs of different steps within Terraform and that configuration. So after that, you can see that after the infrastructure is deployed, our system is going to be looking kind of something like this, where our business tier and data tier are connected with a connection string that's specified, and all of our infrastructure is up there, just waiting to be filled with our applications, but still nothing useful, nothing meaningful yet. So after we're done with that, after we're sure that all of our infrastructure is up and everything is okay, we need to find out what's going to run inside them and how we're going to deploy the applications. So for the purposes of this presentation, we're going to have a React web app as a presentation in the presentation tier, an ASP.NET Core API in the business tier, and an MS SQL server in the data tier. The ways that we're going to deploy these are using the static web apps workflow provided by Microsoft Azure, And for both the .NET Core API and the server, we're going to use the same app service deployment workflow, making use of the entity framework and the migrations that it provides in .NET. Our final product, our final system architecture will look like this, where everyone will be able to use a static web app, an app service, and their SQL server connected together, where we're going to access the system from that web app and interact with it. Finally, we're going to have a look at GitHub Advanced Security and what that means, specifically supply chain security and secret scanning features that it provides. What supply chain security is actually a way to make sure that all the things that make up your end product, all the libraries, all the dependencies, that they are all secure. Because at the end of the day, the more dependencies you have, the bigger an attack vector you have. The bigger you have a surface area for malicious actors to attack you. So if one of them is compromised, you're going to want to be alerted from that as soon as possible. An example of this is the Log4j vulnerability recently, which has affected thousands of enterprises due to them just simply using that one library. We're gonna do that using Dependabot, which is one of GitHub's products that automatically alerts us to security issues and opens pull requests accordingly to bump dependencies and always keep them in their latest version. And then we're going to talk about secret scanning, which is basically GitHub Advanced Security's way of telling us if we've made a mistake in committing database credentials or API keys or service tokens, which can be used again by malicious actors that can either use our cloud resources or use our login keys to do things that we don't want to. So enough talking. Now let's move on to the demo, where we're going to be building the system from scratch. So let me just share my screen. Okay, so can you guys see my screen?
Yep.
Great. So I have two repositories in my GitHub account, which I have published recently. These are a demo backend and a demo frontend. This is an ASP.NET Core repository, and then this is a React web app. I've adapted these from one of Microsoft's sample repositories, which you can also check out in the README. So I've cloned these beforehand, and as you can see, I've made some commits recently. So I just went back into its initial state using Git. So let me just clear this and delete this. So this is our solution that we have right here. It's a .NET solution. So there's nothing. All we need to do right now is simply to deploy it somewhere. So first of all, to do that, we're going to need to set up our infrastructure as code. So for that, I'm going to create a Terraform folder right here in my project root repository. And then I'm going to create two files. It's one main.tf file where I'm going to specify all of the steps that I'm going to need to do, and then a variables.tf file just to specify the variables that I'm going to be using within my main.tf file. You don't necessarily need a variables file, but it's good to have just a single place where you can change everything on the go. So these files use a language called HCL, which is HashiCorp's own language. It's similar to YAML and JSON as configuration languages. So instead of writing it from scratch, I'm just going to be copying. One of the files that I already have previously. So let me just copy my variables file here, and then my main file here. So I'm just going to be going over what each step means, since it may take some time to write this down from scratch. So first of all, in the Terraform block, we specify the providers that we're going to use. For this, we're only going to be using the Azure RM provider, which is and we're also pinning down the version to 3.28. We use a random password resource, which is natively given by HashiCorp, just to make our database passwords. And then we begin with the Azure RM resources. So first of all, we have a resource group, which has an RG reference. And using our variables that we've specified in the variables file, so the project name, the environment, and the location, we're able to create unique names for each resource over here. As you can see, there's many references following this pattern all throughout the file. So once we've done that, and once we've specified its location, we then begin creating the database. For the database, we need two resources, in fact. One is the database itself, and one is the server in which this database is going to run. The settings are pretty straightforward over here. SKU name is like the tier of the database itself. It specifies performance and such. And over here, we specify the admin username, as well as the password, which we're taking from the random password block up there and taking its result. A third resource is also needed for this, which is the firewall rule. The reason for this is that we want it so that only other Azure resources can access this server. So we don't want to open it up to the internet. The way to do this is setting the start and the end IP address to 0.000, which is simply defined behavior for Terraform. That means open it to nowhere and only to other Azure resources. Then we have the service plan in which the service is going to run. We specify the OS type and the SKU name. I've decided to use a Linux web app for this reason. Afterwards, we set up the web app itself, again, linking it with the resource group name, and this time with the service plan's ID. Since we have a .NET Core project, we need to specify the .NET version in our application stack config here. And also, since this will be an API and it will be a cross-origin, there will be cross-origin requests happening. We need to allow cross-origin resource sharing, which can also be done natively in this provider by simply giving everything as an allowed origin over here. Finally, we add a connection string specifying the name of its key, its type, and its value. So the nice thing about HCL over here is that we can reference other resources that have been created. So I can reference this server that I've created up here so that I can construct my connection string meaningfully using its name and its admin login and its admin password. And last but not least, we create a static, an Azure RM static site, which is the static web apps provider over here, which is the simplest of the bunch. We simply just specify those and do everything else from the portal in Azure. So let's just have a quick look at variables over here as well. This is the syntax. You just say variable and then the variable's name or its key, a small description, and then default value for it. So these are not too important. I'm going to be sharing those at the end of the presentation so you can all have a look. So I'll go up here and then I'm going to change the simple app to, for example, 99, just so I'm sure that it's the right one, because there's many different ones. And then let me just run everything that's in here. So as we said, first of all, we perform, let me just go inside. Okay. So we have to do Terraform init at first to Terraform init to initialize. What it's doing is it's checking the resource, the providers that are used here, and it's installing their providers and such accordingly. So after that is done, also you can see here that it's created a small .terraform hidden directory just to store all of this state. After that's done, we can run the Terraform plan command, which basically queries the Azure APIs to make sure that there's no conflicting names, and to make sure that these resources have not been already provided, since this may happen sometimes. At the end of this Terraform plan command, it's going to tell me how many resources it's going to add, if it's going to change anything, and if it's going to destroy anything. Since there's no resources with this name in my account, it simply tells me that it's going to add 8 resources, which are the following. As you can see, there's also many properties that I didn't specify in the main.tf file. These are either defaults or things that are automatically generated accordingly. So we don't need to worry about these too much. And then finally, I can run Terraform apply, confirming that I want to that I know what's going to happen and that I want to apply this plan accordingly. So now we just wait for it to query once more. And when I'm sure that this is what I want, I can just write down yes and begin. So now it's running in the background. It's doing all the provisioning, all the things that it needs to do. And just to show you guys what this looks like, I'm just going to visit my account right here. And I'm going to show you that this is actually running in real time. So we're looking for an RG simple app 099 test West Europe resource group that's going to be created. So the Azure portal may lag a little bit. So I'm just going to refresh every once in a while. It shouldn't take too long to show up here. Yeah, so as you see, without me having to come into the portal and provision and click on create and do all of these things, my resources are automatically being provisioned. And every time I refresh over here, we can see the other resources being provisioned in real time while this is happening. So this may take a while, according to what is being provisioned, especially the backend and the database may take a while. So while this is happening, let me just create the GitHub Actions workflow that we're gonna make so that we can automate this process as well. I know you may be thinking, oh, it's nothing. I just need to, just writing down 3 commands is not much, like Terraform plan, Terraform apply. I can do that. But the benefit of GitHub Actions is having it all be in a central place where everyone in your team has access to it, so that it's not just you who can run the infrastructure, but also other team members if the need arises. So for that, there's a specific format we need to follow, where I'm going to create a hidden directory called .github. And then within that, I'm going to create another directory called workflows. And every file in this workflows directory, every YAML file in this workflow directory, which adheres to the GitHub Actions, format, will be ran. So let's just create a file called infra.yaml. So some of you may be familiar with GitHub Actions, but for those who aren't, GitHub Actions has a specific format where you specify a trigger for what will happen, when a specific event happens, and then you specify the jobs that will run, like run this command, do that, do this action, etc. And the way it works is, so let me just specify the name for this. I can just say infrastructure deployment. And then over here, by writing down on, for example, push to the following branches, I can say every time someone pushes to main, do the following. So let me just, once again, I'm just going to copy paste this right here because we don't have too much time. So we have 2 trigger events. Any pushes to the main branch under the Terraform path. So if someone pushes, for example, application code, we don't want that to re-provision our infrastructure once more. So this is why we specify this. And then workflow dispatch trigger so that we can manually do it. This is a single job workflow with a single job called Terraform. It runs on the latest Ubuntu runner. And it has 4 environment variables that we also specify. You may be wondering, how does Terraform know that it needs to deploy to my Azure account? And this is actually how. You either use the Azure login CLI, or you specify the following environment variables. Since this is sensitive data, it's not correct to commit it directly. So we make use of GitHub secrets here to set up these environment variables, so that even if someone else is contributing to this repository, they cannot see what the actual value of this is. I specify a default for all of the steps in here that says that all of these steps are going to happen within the Terraform working directory. So I don't need to I could have done change directory Terraform before all of these steps, but this is just a nice clean way of doing it. This is a 5-step action. So first it checks out the code from Git. It sets up Terraform into that machine. And then it does exactly what we do, with a small difference in that it does the auto approve step here, so it doesn't have to interactively wait for a yes input, for example. So great, all of our resources have been provisioned from my local computer. So once we refresh this, we can see that, yes, everything is up there. And we can even access the website over here. So once we look at this URL, for example, it tells me that my web app is running and waiting for my content. Furthermore, we can also see this happening for my static web app as well. So right now we're in the very first step that I've showed on the slideshow, where on the second step, where we have all of our resources. We can even see our database up here and the server. So let's just continue and go ahead with the web app deployment. I do want to push this, but there were some issues regarding these environment variables that happened recently. So I will skip the process of pushing the infrastructure workflows, but this won't have too much of a difference on what we're going to do next. So we have all of our infrastructure up here. 1 second. Now let's begin with doing the application deployment for our app service. So the way to do this is very easy. Since this is the first time, sorry, this is not that. Apologies. I've done this like 100 times, so everything's being confusing right now. So okay, our app service 99, which we've done right now. So we go to the deployment center, and from there you need to link your GitHub account. If you're not using GitHub, you may also use Azure DevOps, Azure repos and such. You choose your organization. I'm just choosing my own account, but if you're using GitHub Teams or GitHub Organizations, you may choose that organization if you have given it the correct permissions. So I'm just going to write down tf demo backend. Second. Yeah, and just so that it's not old, let me just push this code really quickly. And I'm going to need to force push this, I think. So 1 second. Add Terraform files. And 1 second. Was it force? Sorry, 1 second. Let me just be sure that everything is correct. Apologies. Okay, I'm just going to check out main and then force push that. So, yeah. Okay, so it's the latest version of our repository right now. So I can continue doing this. I'm going to select the main branch. It's going to add a workflow. However, you could use the available workflows if you want to. We'll preview the file and see what it's going to do for us. So it's similar to what we did in the Terraform step. So first of all, this is a two-step workflow. It builds and then it uploads an artifact, which is then deployed to Azure Web Apps. So this is all good. This is all nice. Let's just save this. Now there's just one step that we're going to need to do, but this is just for the case of this project, since there's a small difference from it. So I'm just going to go to this action and I'm going to cancel it quickly. Because in my case, this automatically generated workflow thinks that it's going to deploy the project root, but I wanted to deploy this this API sub project actually. So what I'm going to do is I'm going to go to the workflow that has been generated for me. And as you have seen me use the defaults for the Terraform for the Terraform workflow, I can use one here too. So I can just say the working directory is this, and I think this is runs, or oh yeah, it's run. Okay. So set working directory for API subproject. I'm just committing to main, but this is not the best practice. But you know, since this is just the setup, this is what I have to do. So now let's have a look. If you've noticed, the Terraform workflow did not activate because we didn't make any changes to the Terraform subdirectory. So we can have a look at what it's doing right now. It's using the .NET build and the .NET publish command to give us an artifact that can then be published instantly to our to our app service. So this doesn't take too long. We can just have a look at it in the meanwhile. And, is my video on, by the way? I don't think my camera is on. I wonder if there's a way to...
Yes. Okay. Everything's fine.
All right. Once. Okay. Let me just... great, so it's been built, and now it takes that artifact that's created into its deployment workflow. So now we'll see. I'd like to remind you that right now we're deploying to both the backend, or to the app service, and also to our SQL server, because what's going to happen is it's going to connect to the server and it's going to run some migrations as part of this code. However, this can, of course, be different according to whatever you do. Great, so it said that it's been deployed. It may take some time to refresh this page. Also, this is HTTPS. That's one of the nice things about... oh, I think I miswrote that. That's one of the nice things about... oh, 1 second. About the app service is that it's automatically signed by Microsoft since it's under their domains. Of course, if you're using a custom domain, it may be different. So we have an API that lists our groups, actually. So once we access that, we should be able to see that. So great, yeah, it works. As you can see, we've just deployed it, and it's showing us the values in our database, which we initialized in the code itself. So it's just showing 3 Microsoft products, you know, the Surface, the HoloLens, and the Xbox. So now all that's left is deploying a front end so that we can access this, or other users can access this through a presentation layer. Of course, if the nice thing about this too is also that we have a separation of concerns, so that, for example, if we have a backend team and a front-end team, the backend can be updated without having to stop or having to redeploy the front end in such cases. So now let's move on to the front-end repository. And over here, okay, I'm going to do the same thing. I just need to, yeah, 1 second. Okay, so I just brought it back to the way it was previously. This is also another sample app. It's from the exact same repository. You guys can have a look at it whenever you want to. So what I'm going to do now is I'm going to set up a workflow for that as well. And to do that, we're going to need to go into the simple web app page here. And then we're going to need to copy our deployment token that we have here so that we can deploy it. Once we do that, we can simply just go to the actions page over here. And then in new workflow, we can specify that we want a static web apps workflow, which is great because we just have this workflow is already ready and made for us by Microsoft Azure. So let's just configure this. It's pretty easy to tell. It has some pretty clear instructions. All we need to do is set up this GitHub secret within our deployment so that we can have it automatically deploy. And this is just a one-time thing, so we don't have to do this whenever we redeploy. Our environment variables here are just what we need. But there's one more variable that we're going to need to add, but this is just for our application. So to access the backend, we have a React app API base environment variable. And to that, we can just hard code, we can either hard code the URL that we have here of this app service, or we can set it up as a secret or as a variable within the repository so that we don't need to change this every time. For the sake of this presentation, I'm just going to write it down here. So great, we have that. Before we do this, let's just configure our token. So to configure secrets, we go to the repository settings, we go to secrets and variables, and then we go to actions here. We can add a new repository secret. So in this case, it's supposed to be Azure Static Web Apps API token. And then we just copy the token that we had. We copy the token that we had over here, the deployment token. And then we paste that into the secret. The nice thing about secrets is that they are read only. So once we write them down, no one, oh, sorry, I've already added that. No one, not even yourself, can read that secret. So let me just write it down again, since it was already there. And its name. So even if you have access to this repo, you don't, only GitHub actually knows what this is. And even when they're used in actions, they are automatically removed so that they don't show up in the logs of the actions themselves. So great, we added everything. Everything is ready right here. So let's just go ahead and commit this. So as soon as we commit, we should be able to see the run happening, as you can see here. So let's see what that's going to do. It builds and deploys all at once. The way that this works is it actually uses Microsoft's Oryx app, which is a great project that automates build processes by automatically scanning the repository that it's in. So it can tell if it's a React project, what it needs to do, if it's NPM, if it's Yarn, etc., etc., and it can build everything automatically, which is just great. So this shouldn't take as long as our backend deployment. It's just going to do an npm install and run and deploy everything. So as you can see, it's the Oryx build logs right here. Let's just wait for that. So as you see, it's a fairly straightforward process, and the nice thing about it is, due to the fact that all of this is automated, we actually don't need to do this ever again, unless some issues arise. So once you do this, you as a developer or your development team can just continue doing what they do best without having to worry about what the infrastructure is or how they're going to deploy it and such. So it's just doing an install. Should be done in a couple of seconds. Great, so everything's been uploaded. Yes, go ahead, Vlatko.
No worries. I thought, if this takes a bit time, I just wanted, for the guys join the team, just to introduce the program and how we build this kind of a cooperation, between me and you, right? So because it's still running. Let's just leave it there, and I can just explain. For those, I think that many of you are joined a bit, couple of minutes after we started. The thing is that this is part of the Microsoft Learn Students Ambassador Program, where all the students, across the world can participate in and can become the ones, that can start using the benefits into this program, out of this program. And one of them is just, having a mentor that can work with them and just make them, aware from for the problems and challenges and solutions as well that we, myself as a MVP, we are facing on the ground. With and just face these guys with real life. Challenges. It means that we started a couple of months ago, and we started. Slightly. I'm just exploring. What Ali. From my side, I just did like a few conversations with Ali. What are his aspirations there? What are his skills as well? So we combine and assemble the dots, and after we decided, to create one plan where he can grow his career. Whatever you're seeing right now was built with a very limited time, I would say, but big effort from Ali's side, because he explored many of these things with my recommendations and advice. The thing is, there is a plenty of improvements that can be done. Right now, as you mentioned, like a password for SQL Server, we are not applying any networking layer on top of that one, no access control, so like advanced security practices and patterns apply, but this is just like a baseline showing an end-to-end simple product delivery or project delivery life cycle before we can actually grow those skills at the level that can be more and more professional. So I'll pause here, Ali, just go ahead. Really
Thank
well
you.
done, and everything, what you have done, and your I can see commitment to the work that we have agreed during few of our meetings in the past, just resulted in something that you are very familiar with. You can handle even some of the errors or glitches that can happen through the presentation, but this is a really nice showcase how this cooperation between MVPs and Microsoft Learn student ambassadors can go well.
Thank you so much, Vlatko, and I have to say that it has been a great process going along with you and learning all of these. As you've said, being a Microsoft Learn Student Ambassador has also been very beneficial to me. For example, like I would not be able to do these deployments all the time if I didn't get, the Azure credits that I'm getting from the program and such, and not having been able to meet, people like you and do such projects. So thank you for that. So now our deployment is done. I can just visit it right away. You guys can visit it too. So it's an unfinished project, but the important thing here is that let me just open DevTools right here. It communicates with our backend that we just created. So if I go to this groups page over here, as you can see, it sends a GET request, and it's a cross-origin GET request to not this URL, to another URL complete, which is our backend URL. And accordingly, it renders the data over here. So it's, as you can see, this is end-to-end. What's happening here is it's sending a request to the backend. The backend is creating a SQL query. It's taking that back and returning it to the front end. And this is how our project finishes. So now, just to show the benefits of this continuous deployment, let me just change a little thing. For example, I can change this title. So it's not my first React app. Let it be, the title of this presentation. So let me just come here and 1 second. Let me just go to my front end project directory here, and I'll just search this. And I'm going to change this title. Continuous deployment. So let me just commit this right away, and you can see that it's going to change instantly. Change title. Oh, I need to pull. Yeah, 1 second. Okay, so again, there's going to be a little wait for this. So in the meanwhile, I just open it. While this is happening, I can move on to GitHub Advanced Security, which has also been one of the topics that we've talked about along with Vlatko. So as developers, we're not too, we don't think too much of the security implications of the things that we do. Maybe the most that we've done is, like hash maybe the password inputs or sanitize SQL queries. But there's many more things that are involved in that. Many more things that can happen by accident that can completely ruin the security of our deployments out there in the real world. Because there's malicious actors, and at some point, it's not going to be like all the projects we do in university and such. There's going to be people with a vested interest in actually destroying your deployments and such. So for that, we can make use of Dependabot. Dependabot, as I've explained, automatically shows vulnerabilities within the supply chain security, within your supply chain, and creates pull requests automatically and gives you alerts automatically accordingly. So to do that, we can go to settings over here to activate Dependabot. We can go to code security and analysis in the bottom left, and now we can enable Dependabot. So I already had it enabled, the alert notifications, the security updates. We can even enable, let it tell us if there's version updates as well. So for this, I can just specify that, I use the npm package system for this front end. And then I can commit this over here. And now once I do this, whenever there's an update to one of my dependencies that's specified in this package.json file, Dependabot will be sure to let me know and send me a notification up here. So previously it has created pull requests to bump the dependencies here. So the nice thing is that it's a pull request, so I can just check out this branch and I can see if it really works. Or if I have CI tests, which would be even better, I can just check, if it's working. I just merge it right away. And then here in the security overview, we can also see the vulnerability alerts that Dependabot sends us. So there's critical alerts, there's high alerts. They have very detailed information about the things about what the issue is, so severity and what the problem is. So yeah, let me just go back. So along with that, for secret scanning, it's on by default for most public repositories. However, in your organization, you may need to come here to code security analysis and enable it from the bottom left of this. So what's going to happen is that every time you push, every time code is pushed, it's going to be automatically analyzed by GitHub and its secret scanning partners to see if any of their secrets are in your repo. So for example, let's say I use Twilio, for example, for my for sending SMSs to my customers. If I have my Twilio service tokens or my API keys pushed there, and if Twilio is a GitHub secret scanning partner, it's going to let GitHub know instantly according to some rules, like regex patterns and such, if there's an issue, and it can even prevent pushes from happening. So you can do that in two ways, where you can have it alert afterwards, or where it can do the analysis before the push is accepted and let you know, where you can override the push as well. So that's all for today. Let me just check that this deployment happened. Yes, so let me just refresh this page. And as you can see, it has been updated automatically using the CD workflow that we have worked on from the beginning of this presentation. So that's it for the demo. And now, 1 second. Now we can move on to any questions or anything you would like to have. Oh, I'm sorry, I forgot. We have some next steps that we could do for anyone who wants to dive deeper into this, which is you could automate the configuration setup itself. So by using the Azure CLI, you can have, and the GitHub APIs, you can have it so that even those secret settings and such are automatically done if you do it properly. You could set up custom domains, so you don't have to rely on Azure's automatically generated domains. You could authenticate the database with Azure Active Directory credentials, which is also another security feature, so that you don't even need a login and a password, so that you don't need to even worry about secrets and what they are, like Vlatko have said. Furthermore, you could add linting, code quality checks, and testing before the deployment steps, so that if that step fails, the deployment does not happen, which is a great way to keep your to prevent erroneous deployments and prevent pushing bugs or errors or regressions into production. So that's it. Thank you all for attending, and I'd like to hear if you have any questions, and please let us know. Thank you. And thanks to Vlatko for his great mentorship throughout this whole process.
I just wanted to I would say comment on a lot of improvements or the upcoming features. I mean, especially in GitHub. I mean, this is a wide area, So, for example, I mean, I'm not sure. I mean, Ali, we can follow up on this. I mean, in a separate call, just to understand what's the mentorship program and when it ends. What's the? I mean, can we continue, or I should be assigned to another mentee? I mean, that's probably something that the MVP and MLSA program, I mean, should decide, I mean, how we would like to continue. But definitely, also improving on this meta means, I mean, first of all, securing your stuff. Second is probably enabling a full automation, which means we don't want to maintain a separate workflows for each of the environments, but we can probably use a multi-stage deployment. So whenever you're creating a package, I mean, and probably a package system, I mean, which can store these packages, they can version them. And whenever you're deploying, let's say in dev test, you can use the same output to provision or to apply to the upper environments as well. So there's plenty of other stuff like a branching and merging strategies, security posture. Currently, I would say this Microsoft Defender for Cloud enabled Microsoft Defender for DevOps as well, which is a very new feature still in preview, which means that your Azure Security Center can connect to your GitHub or Azure DevOps and can get all the things that can be automatically identified for the whole organizational account, including all the repos, by using advanced GitHub security features. As you mentioned, for once, I mean, like a dependable or GraphQL for the vulnerability scanning or credential scanning or a few other of them, I mean, that are available within the palette of security features. So it means it will be embedding like these security findings directly into a security center, which will contribute to the overall product or project score, which means aggregating not only the Azure infrastructure side of working or Defender for, let's say, for cloud on a different resource types, but pulling these results out of I would say it's like a requirements management and orchestration tool that we are using for enabling this continuous integration or continuous deployment. So that's a bit comment from my side. If there are any questions, guys, I mean, go ahead. If no questions, Ali, we can close off this call.
All right. Thank you all so much for attending. I appreciate you taking the time from your day to attend. This was actually my very first presentation as a student ambassador, which I've done to such an audience. So thank you so much once again, and especially you, Vlatko. We could follow up if you'd like after this is done. I really appreciate all the work that you've done and the time that you've made for me and for moving this project forward. And yes, that's all from me.
Yeah, I can just, I mean, thanks, Ali. I can just ask if you can share some material, I mean, with the guys in this chat window, I mean, or just the repo if it's public, I mean, so they can see the examples and everything else. Right?
Of course.
Will be very useful.
The repository is, are these two. It's the TF demo frontend and the TF demo backend. The web page is as such, the one that's deployed right now. I'm going to deprovision it possibly within this week. I don't have infinite credits on Azure, but and this is also the backend.
Yeah.
Right there.
Okay. you can also share the PowerPoint deck as well, right? I mean, just you can do it afterwards, right? Just maybe you can store in a OneDrive or SharePoint. I mean, you can just share the link here in the same chat.
All
Perfect.
right.
Cool.
Great. So thank you all so much for coming,
Everyone.
and have a nice day.
Cheers. Bye.
Goodbye.